I'm not going to make any new examples for this, but I want to use the old examples so we can use the second derivative test. So this is how we use the second derivative test. It tests concave up and concave down. We solved earlier that the derivative of this function here, dy over dx, or let's say y prime, just to save time, is 6x plus 5. If we take another derivative, so the double derivative, it's 6. Now, that means for the entire function, the function is concave up, since the double derivative is positive. If it's concave up, that means we have a minimum at a certain point. I know it sounds counterintuitive, but just remember that if you have concave up, you have a minimum, and if you have concave down, it's a maximum. So that means at the point which we solved earlier, negative x equals negative 5 over 6, we can confirm that this is a minimum because the second derivative test shows that the second derivative is positive. It's concave up. Let's look at this example. Y equals x to the fourth plus 4x, which was also seen in the previous video, first derivative test. Y prime equals to 4x cubed plus 4. Then y double prime equals to 12x squared. We found earlier that the value where the critical point was 0 was at x equals negative 1. That was in the previous video. That means if we put in negative 1 for x here, we get 12 times negative 1 times negative 1, or just 12. Same thing here. If it's concave up, that means we have a minimum. So at x equals negative 1, we also have a minimum. Just remember, if we have like y double prime equals, let's say, negative 5, that means it's concave down. When it's concave down, there's a maximum at that point. That's just to clarify. And this is the second derivative test. It is very easy, and it is used best when the first derivative test seems too complicated. So just remember that.